So now we have come to AC voltage applied to a series LCR circuit. Now if you talk about LCR, what is mean? L is for inductor, C is for capacitance, and R is for resistance. ISTNC. So this is what LCR circuit means. So now if I want to solve this for our LCR circuit, let's draw a circuit where all of this is there. Now this is my alternating voltage, this is my resistance R, this is my capacitance C, and this is my inductor L. This is L, this is C, L. So what will happen when these are connected in series? Now please look over here, these are all connected in series. So let's have the derivation or the analytical solution. Analytical solution. Now you know this is a closed loop, so we will be applying Kirchhoff's law for closed loop. So if you take the closed loop, what you have is, if you go from here to this point, if you go from here to here, this point, this is positive and this is negative. So from plus to minus, I have minus R. So now this is positive. If charges is flowing, so this becomes positive, this becomes negative. So I am going from positive to negative. So this becomes my negative Q upon C. Now this is R and this is I. Sorry, I did not write I. This is Ri. So the voltage across this Ri. See, this is positive. So positive is coming here, so it's negative. So this is my negative sign convention. Now over here, that is minus of L di upon dt. Plus, if you look over here, plus from minus to plus, this is going from minus to plus, so we'll have a plus, that is a plus potential, which is equal to 0 by Kirchhoff's law, that is total E is equal to 0. Now writing this properly, we have V equals to Ri plus Q upon C plus L di upon dt. So this is what we have. Now say suppose let's integrate this with time t. If I integrate this with time t, what will happen is, now V was actually, first let me simplify this, V was actually equal to Vm sin omega t, which is equal to Ri plus Qc plus L di upon dt. So this was my complete form. Now why did I differentiate this with time t? I differentiate this with time t because I is actually equal to dq upon dt. So I need this dq upon dt term to get my I. So now all of this equation becomes, if I differentiate this with time t, this becomes, this is what? I is actually what? dq upon dt. So again I further differentiate this, then this becomes pardon, then this becomes R into I'll write this in this way, dq upon dt plus qc, it will remain because it's a constant term, q for this capacitor, plus L. I is dq upon dt, which is again differentiated. So this becomes d square q upon dt square, which is equal to Vm sin omega t. So I'm writing this in my next slide, and this gives me So this is my complete equation. This is my complete equation. Now, if you observe this particular equation, we had this in our class 11 chapter for damped oscillation, and this is a differential equation in 2 dimension. That is, its degree is 2. Differential equation in degree 2. So now you have, say, suppose Q is equal to Qm sine omega t plus phi. See, therefore dq upon dt will give you omega into Qm into cos omega t plus phi. Further double differentiating, you will have dt square. Say suppose we have taken Q to be a sinusoidal, that is the charge that flows because of the alternating potential, there will be a alternating current, and because of a alternating current there will be a alternating charge that is flowing through the circuit. So this is the basic concept. So that's why we have taken a alternating flow of charge where Qm is its max or peak and sine omega t. Differentiating, this comes over here. Again further double differentiating, this becomes minus omega square Q of m into sine omega t plus phi. That is dq upon dt square. So if we put all the expression, that is d square q upon dt square, dq upon dt and q in this particular equation, name this as equation A. So if we put all this in equation A, what we will have is Qm into omega. I am taking Qm into omega common, that is R cos of omega t plus theta plus xc minus xl. Now we are coming to this part, xc minus xl into sine omega, this is sine, this is omega t plus theta, omega t plus theta, now which is equal to Vm sine omega t. Now the right hand side will exactly be same. Now if you look over here, L, this was L, so this was L and this was R. Now R was what? dq upon dt. If you look at dq upon dt, that is omega into Qm into cos omega t plus theta. So we have R, that is R because of this. If I break this down step by step, R, omega into Qm gets taken common, it is taken common. So R into cos omega t, that is coming from over here. Now if you look over here, d square q minus dt square, this is what? Minus omega square q, minus omega square q, and q upon c. Q upon c was Qm sine omega t. So if you write, say suppose I am writing this over here, this is R, so sorry, this is L, and dq upon dt is actually equal to d square, sorry, this I am talking about d square q upon dt square. So d square q upon dt square is minus omega square Qm into sine omega t plus theta. And what is this? Q upon c is nothing but your plus 1 by c. What is q? This is Qm upon sine omega t plus theta. So if you take sine omega t plus theta common, you have L minus L omega square by Qm plus Qm upon c, and this becomes sine omega t plus theta. So till now over here we are clear. How did in your NCERT book you had this? We are trying to say what were the steps involved for your this particular step, So I hope till now you are clear with this. if you just put the value of d square q and dt square, you will have this L into minus L into d square q upon dt square is given by d square q upon dt minus q this. So now if you take q upon m common, I am writing this over here. If you now take q into omega common, what you are left with is minus L omega. You are left with minus L omega. And over here what you are left with is, this is q and this is omega. So 1 by c omega, you are left with minus L omega plus 1 by c omega. This is sine omega t if you are taking this constant. Now if you look closely over here, what is 1 by CW? What is 1 by CW? 1 by CW was nothing but your XC that we have derived earlier. And what was minus LW was nothing but your minus of L 1 by omega, which was nothing but your XL. So this is minus XL. So minus XL is taken over here and XC is taken over here, and this is the step that has been missing from your book. So you can understand this step from over here. So so if I write this in a proper way in my next slide, let's have a look. So if I finally write, I will write like this. Vm sine omega t is equal to Qm upon omega. This is R cos omega t plus theta plus Xc minus XL into sine omega t plus theta. So this is what I will write. Now we have used the relation x equals to 1 by omega c and xl is equal to omega l. This is the relation that we had used. So please do not get confused. Now if we multiply and divide equation this by, say suppose if we are multiplying and dividing this particular equation, say equation A, by z equals to root over of r square plus xc minus xl, this is whole square, z equals this, then we have qm omega into z upon r by z into cos omega t plus theta plus xc minus xl by z into sine omega t plus theta, and the right hand side, that is this part, remains exactly the same. This part remains exactly the same.